Title? Title. With a T. Thank you. All right, so we can take a look at that. Oh, but then I called it 1.5 here for some stupid reason. Silly Joe. All right, there we go. So, we don't just want to learn that chemical reactions happen. We want to actually be able to kind of predict what will happen when things react. We want to kind of know what types of chemical reactions we'll get. And to do that, we want to look at the different types of reactions we can get. And the easiest one is, we said a chemical reaction can either happen when we break bonds apart or when we make things, put bonds together. So we're going to look at the first of that, just making compounds by making bonds, by putting things together. And we call these synthesis reactions. That happens to be a word I hate trying to say, synthesis. So if I like slur my way through it, you'll have to excuse my inarticulate nature. Here's the basic idea. Thanks. The basic idea for a synthesis reaction is that you take something, doesn't matter what it is, and you react it with some other thing, doesn't matter what it is, and those are going to make some new thing, a single thing put together. And this thing here will be a compound of A and B. And we don't know how many of each, right? It might take 3 A's and 5 B's, or it might take 2 A's and 4 B's, or it might take whatever. So the other way you could write it if you wanted to is you could say A plus B is going to give us A question mark, B question mark. Does that kind of make sense? We're going to make a compound. And while we're at it, we might note that it might take 2 A's, or it might take 3, or it might take 4 to make this happen. It might take 1, 2, or 3 B's. So we can't balance it until we know what the reaction is. Does that make sense? We're going to have to figure out what the reaction is, what it makes, and then we can balance it. If I wanted to, I could go in the back, and I have a jar with some sulfur powder, and I have a jar with some lithium metal. And if we wanted to, we could put them together. And we could put them in the fume hood because sulfur stinks when it burns. And we could put it under a Bunsen burner. Not under a Bunsen burner. Under a Bunsen burner, it wouldn't get hot at all. Rather, we could put a Bunsen burner under it, let it react, and it would make a new compound. The lithium would bump into the sulfur, and they'd stick together. Does that make sense? So when these things react, one thing we note is we need to predict what the product will be. And that's why we did that practice early on, looking at ionic compounds. And we're mostly going to stick with things that make ionic compounds. So, what is the symbol for lithium? Li, very good. And what is the symbol for sulfur? Find up there, I think it's number 19. Was it 16? Darn it. Oh, 19 would be, yeah, that's silly, Joe. So 16, what is it? Yeah. Yeah, what's the symbol? Yeah, what's the symbol? Excellent. Thank you. And when these react, notice, by the way, I'm leaving some space around them. Why do I need some space around them? What might I have to add? What might need to go in here? Some number to balance it, right? I might need 2 of these, or I might need 4 of these. Maybe I need 13 of these. Probably not. And then the question is, what will they make? What will they form? So we can say that lithium is going to react with sulfur, and it's going to form something, but you already know what it's going to form. If lithium and sulfur bump into each other, how do they react? You already know this. What's lithium going to do? Is it going to share electrons with sulfur? Yes or no, why or why not? Will lithium share electrons with sulfur? Yeah. Okay, why will it give as opposed to taking, as opposed to sharing? Because you're right. You're totally right. Somebody want to help her? Why can't lithium take electrons from sulfur? In some Robin Hood-like situation where lithium steals from the electron-rich sulfur, and the answer is that's just not how it works, right? In chemistry, the electron-rich get richer, and the electron-poor get poorer. So lithium is going to give electrons to sulfur. We could draw this if we wanted to, but instead what we usually say, or what I usually encourage saying is, let's predict the product, but the name of the product is going to be the ionic compound of lithium and sulfur, which we're just going to call lithium. What would it be called? When we put lithium and sulfur together, we'll get lithium sulfur becomes lithium. Very good. Excellent. Lithium sulfide. You guys are good. You're picking up on this very well. And how many electrons can lithium give away? If we look at its location on the periodic table, how many electrons can it give away? Yeah, let's take a look at lithium. Where's my pointing stick? I don't even know where it is, man. I have to use God's. It is one. I have to use God's pointing stick. This one has my hands. Yeah, lithium only has one electron in its outer shell, so it can only give away one electron. And that means that if I had, oh, thank you. God bless you. Toby, you're good people. I'm probably not going to wave the broom at the periodic table, but it's nice to know I can if I need to. So one lithium would give away one electron. If I drew a second lithium, it would be able to give away 2 electrons. 3 of them all together would be able to give away 3. Not very exciting there. What about sulfur? Sulfur is going to take electrons. How many electrons does sulfur need to take before it's done taken, before it's got a full shell? Yeah, if it took away just 1, then it would only be like chlorine, which still wants electrons. So it needs to take away 2. Good. So we show that how? Lithium, we say +1, because when you give away electrons, you become positive. When you take electrons, you become, so we'll say -2. And one sulfur could take 2 electrons, 2 of them could take 4, 3 of them could take 6. We could keep going if we wanted to, but we don't. Is there a match here? Is there a nice combination? Yeah, and the nice combo is that a single sulfur can give away 2 electrons, but to give 2 electrons, we need how many lithiums? 2 of them. So what's the formula of lithium sulfide? How many lithiums? 2, so that'd be Li2. And then how many sulfurs? Nope, how many? Just 1. Good, so that'd be Li. And do we write the 1? You could, but it's clumsy. You normally just write it like that. That's our reaction. So that's the first step. The first step is you have to predict the product. You have to find the formula of the product. And there's no shortcut. Every single time, we're just going to have to do this. Now, again, you may do this in your head. You may like to do this better by drawing. You might have seen that and said, okay, I've got lithium, it's got 1 electron, and I've got sulfur, it's got 1, 2, 3, 4, 5, and 6. And lithium's going to give an electron away, but the sulfur still isn't happy, so a second lithium's going to give its electron away, and that helps you go, okay, that's 2 lithiums, 1 sulfur. If you'd rather draw it, go nuts. Nothing wrong with that. I like my little table, because I think with the little table, for me, I'm not very visual. If I draw this table and I look at the math a couple of times, after that I start to do it in my head. But if you're more likely to start doing it in your head by drawing it, if you're a bit more visual spatial, draw it every time. That's fine. Eventually you'll just see it. That takes some time. And I shouldn't say that for everyone. Probably some people don't eventually just see it, and that's okay. You can always draw the table. You can always draw the actual atoms, as long as you have some method that works for you. Does anyone not understand how we got this? Because now's a great time to ask. I'm here for you. Toby's here for you. Heimpel's here for you. Emily's not here for you, but if she were, she'd help you too. We're a team. We learn together. All right, now what's the only problem with this reaction? What doesn't work about it as it's written? This says that if a lithium atom bumps into a sulfur atom, they form the compound lithium sulfide, which is Li2S. What doesn't work about that? This relates to what we talked about yesterday. What doesn't work about this? Yeah, can we focus in while I'm talking? Because, you learn a lot better if you're focused on what we're talking about. So, and this gentleman trying to focus. So, the question is, this reaction says lithium bumps into sulfur, one atom bumps into one atom, and we get the compound lithium sulfide, which is true. This is what has to happen, but we know from when we drew it, there's something not quite true about this. What do we notice whether we drew it this way or whether we looked at the table? What do we notice about this equation that doesn't work? Yeah. It's not balanced. Because according to this, one lithium and one sulfur can make Li2S, but that doesn't make sense. So step 2 is going to be to balance. And when we balance it, you might be able to do it in your head, which is great. I'm going to draw it. I'm going to say on the left side and on the right side, and I'm just going to count atoms. And this one's fairly easy because all I have to look at is lithium and sulfur. On the left side of this right now, how many lithiums? Yeah, just one. Beautiful. What about on the right? How many lithiums? 2. Good. On the left side, how many sulfurs? 1. And on the right side, how many sulfurs? Yeah, good. So sulfur is fine, but lithium, I need 2 here. Should I make it like that? No, that would imply that lithium comes to us stuck together, that it's diatomic, but it's not. Lithium you can get single atoms from. There may be a lot of them in a piece of metal, but the chemistry actually works that they can be pulled off one at a time. So you can work with one lithium atom. So the number 2 has to go where? Out in front. That's the only place we ever put numbers when we balance. We put numbers in front. And now that changes this 1 to a 2, and now this is balanced. Does that make sense? Howdy.
I have a quick question.
Sure.
Do you have an assignment?
Probably.
Because if you do, can I have it back so I know if I need to study it?
Yeah, for sure. You didn't get yours back?
No.
Oh, interesting. Yeah, I'll take a look.
Okay.
I thought Ruby handed them all back.
And
Did Ruby drop my class or has she been away?
I don't know.
I haven't seen Ruby. She's my peer tutor. She's excellent. She's doing very well. And then now she's gone. Don't you leave me too. My goal is to have less and less of my job to do, not more and more. Yeah, I'll find it because I know it was in there. Like there's a mark for you, so it got marked.
Did you print the practices?
I will.
Okay.
I will. So yeah, swing by at lunch and we'll get both those for you. Okay.
Okay.
Cool. No problem. Anytime. All right. Let's take a look then. We'll try a couple more, but first a reminder, and we've mentioned this a couple times, but just one thing to note is that anytime you work with hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, or chlorine, you have to make sure that you always treat them just when they're by themselves. When alone, they're always paired up as H2O2, F2, Br2, I2, N2, Cl2. That has nothing to do whatsoever with once they end up in a compound. It's just when they are alone. Write them as whatever it is, 2. Again, once they're in a compound, you just work it out just like we did here. Can we try one more together? And then I'll give you a little bit of practice on your own. Or are you feeling ready and you want to try one on your own? One on your own? Okay, so see if you can do this. Aluminum reacts with oxygen gas. Aluminum is going to react with oxygen gas. So you're going to follow the same 2 steps you did above, which is over here, you're going to have to figure out what the product is. So step 1 is figure out the formula of the product. All right, if you want to do that by drawing it, great. If you want to do that by working it out, that's great. And then step 2 is balance it. All right, give it a try. I'll be around. But if you're doing that, that's great. I'm going to make myself a quick coffee. Chobi's going to walk around and make sure you're doing good. And be teams, help each other out, but try it on your own for a few minutes first. Fight with it a little bit. It's good to fight mentally with things, not physically. Right, Heimel? I'm dragging today again. I was dragging yesterday, and I thought if I get a good night's sleep, I'll be wide awake. And then I got to bed last night by like 11:30, which for me is pretty good. And I woke up at like 3:30. And I was like, well, that didn't end up being a very good sleep, did it? Flourish. He's trying to get your attention. You have a big head. That's a compliment, though. He means you're very smart. But also, could you move your big smart head? That's what he means. He's complimenting your intelligence. I think he is. I am anyway. Whatever he meant. I mean that you're very clever. How's this feeling? Does it make some kind of sense? That's probably new to you. So does that make any kind of sense at all? Yeah. Does it? Okay. Good. That's not how most teachers show it. Obviously, you won't taught it that way. You're feeling good. Sorry. Sure, I'll bring it to you. You're welcome. Yes, ma'am. Oh, here and then there. Yes, ma'am. Beautiful. Yep. And that's correct there as well. So now the only thing you have to do is balance it. This one's kind of miserable to balance. A little bit miserable. But I have faith in you. Yeah, did you not get one? Well, let me find you one. No, I'll get you one. Yeah, that one. Does yours have a note on the back? What's the note? That's me teaching blood types. What's wrong with me? Yeah, we'll give them that later. I like to make them. I like to make them work without it first, and then I give it to them, and it seems nice. You know. And, hi. What's up? Yeah, good luck. That's good. These guys are working on something. Thank you. So easy to help. No, you are. You have very different intimidating. No, this is different, right? Like, you got mom and you do. You shot. There's a fierceness there. People fear you. You did that there. You really did. Something you'll say. Like, so good prediction. That's right. Two of those. That you're super close. That two just needs to go in front of the whole thing. You can't put it there. And when it goes in front of the whole thing, it's going to change the O3 to make it match. That's awesome. But then you're going to have to fix your aluminum. And that's what makes these so annoying, is because when you put that in to fix the oxygen, it breaks the aluminum and you'll need to fix it again. Does that make sense? Try that. But that was great. You got the right numbers. You just cheated the system. You can't put it in the middle of the valve. ruining everything. Yeah, no. I dropped a lot of stuff. It's a big mess in there right now. Within just a second.
For left side and right side thing, I forget what to put. Like, you want to put this number down, or you want to put?
No, aluminum doesn't take a positive 2 charge.
What do you mean?
It doesn't take a positive 2 charge.
Like, what exactly?
It takes a positive 2 charge.
Oh, okay. Oh, I thought it was like
Can I take a look?
4, and it didn't have clean.
Yep. Yep. Cool. Now I just want you to write it neatly. Okay, so that's all good. So now just make sure you write it in a nice, neat line, just like we see here, so it's clean. But the answer is great. All right. Remember when I said that balancing could get miserable? This is miserable balancing, I think.
No, it's not.
No? Oh, I find this tricky. Because like you fix one thing and then something else breaks and then you're sad.
Early on things.
Yeah. Yeah. Can I see? Okay, so the first thing is the arrow shows the reaction happening, but we don't use an arrow to show that there's two things over here. Same with here. It's that plus sign, right? Right? A plus B. That's saying these two things react together. So let's change that to a plus. That's good. Okay, now, this is exactly right. Beautiful. Now we have to balance it. And the first thing after we know when to balance is that O can never be O by itself. It's got to be O2. Now that's going to screw your whole thing up because we don't want 2. We want 3. And there's nothing you can multiply 2 by to give you 3. So you're going to have to meet at, where could they meet up? Well, if we doubled this, now how many oxygens do we have? We have 3. We doubled it, so now we have, no, what's 2 times 3? 2 groups of 3 is, does that make sense? If every one of these has 3 oxygens, if we take 2 of those, now we have 6 oxygens, right? And over here right now we have 2. What can I put in front of that now? What can I multiply this by so we have 6? Beautiful. Exactly right. Is that 3 or did I do it backwards? That's 3. I'm looking at it. Does that make sense? And now how many aluminums do we have? Each one has 2, but we have 2 of them. How many aluminums total do we have over here? Beautiful. Exactly right. Exactly right. That's 4. And then what number has to go here? Does that make sense? It's weird at first. I find this, like, to me, that's a jump in difficulty. So that's okay. We're going to get some time to practice. So we'll take that up together if that's okay. Does anyone else want help individually before we take it up together? Or are we good to do it as a group? Okay. We'll do it as a group. By the way, don't ever be shy or feel embarrassed to ask for help. If you do ever feel embarrassed, I want you to go back there and look at the mess I just made trying to make a cup of coffee. Because it looks like there's something, like you'd go back and you'd be like, I think there's something deeply wrong with Mr. Orlando. I think he's failing at basic life skills. And so however, if you ever feel like, oh no, I don't know how to do this chemistry thing that I've never seen before, it can bring you comfort to be like, oh, Orlando probably makes a cup of coffee every day and has for the last 27 years of his life, and he just screwed that up, like majorly. So like, don't ever be, you got nothing to be embarrassed about with me. The dumbest thing you ever do in this class will not come close to the dumbest thing I'll probably do in this class. I'm going to win that prize, I promise. So, I know sometimes people get all like embarrassed if they're like, I don't understand what I'm doing, and that upsets me. But shouldn't. You should just feel, I feel like I'm going to knock this off today and like scold myself. I'm really having a clumsy day. All right, so when we work this out, the first thing we note is that aluminum has what symbol? Fantastic. And oxygen? Very good, O2. And if you remember to do this now, all the better. If you forget until balancing time, that's okay. But the best thing is if we can remember right away, right, it's going to be O2. Now, when we go to work the product out, we have to figure out what it is. And aluminum is going to react with oxygen. Given aluminum's spot on the periodic table, how many electrons is it going to lose?
3.
Yeah, very good. Can everyone see that? It's got 1, to 3 electrons to lose. And how do we show that it's lost 3 electrons by convention? Because electrons are negative, so we say each one is positive 3. Good. And that means one of them could lose 3 electrons, 2 of them could lose 6, 3 of them could lose 9, and you could keep going. 4 could lose 12, 5 could lose 15, but 3 usually gets us there. What about oxygen? How many electrons can it gain? Yeah. Oxygen can gain 2 electrons. And so the first oxygen could gain 2 electrons. The next one would give us a total of 4. Next one would give us a total of 6, and so on and so forth, 8, 10, 12. But we get our match. Where's the nice match happen? Very good. 2 aluminums will give up 6 electrons, but it's going to take us 3 oxygens to accept those. And so the formula of this thing ends up being 2 aluminums and 3 oxygens. How would we write that? AL O. Beautiful. Very good. And what would that be called? Not just product, but we'd call it? Yep. Very good. Aluminum oxide. And if you're British, you'd call it aluminium oxide. They give it an extra E. Oh, God, that's really hot. Well, that's what I mean. In French, we call that an E. And in Italian, we call it an E. And you know what's even better? In French, we call this letter an E, and it makes all kinds of sounds. In Italian, you call this letter an E, and you know what sound it makes every single time? E. In Italian, we call this letter A, and you know what sound it makes every time? Ah. They call this A, and you know what sound it makes every time? A. They call this one O, and you know what sound it makes every time? O. And they call this one Oo, and you know what sound it makes every time? Wouldn't that be nice if the vowels just actually made the sound they're supposed to make? English, okay, what sound does this vowel make in English? O. Okay. What about here? Ah. Yeah. What other sounds can it make? What about here? Ooh. Okay. What else? Okay. Yeah. Okay, it can also make an sound. Why not a U? Like book should be spelled like this, right? Obviously, but it's not. That is how it should be spelled. Right? But it should, right? Like why in the world is it with 2 O's, which is supposed to make an oo sound? So this should be a book, but it's not. It's a book. And then here's one for you. What sound is that? Yeah, say it. Say it naturally. Women. No, say it naturally, the way we actually say it. Women. This also makes an sound. Why? Why does it make an sound? I don't know why it makes an sound. It shouldn't make an sound. It's supposed to make an O sound. English sucks. I mean, it's amazing. It's beautiful, but it's so stupid. Can you imagine? Did anyone here learn English as their second language? I didn't. I can't imagine. Right? So again, I took Italian classes. Italian, the pronunciation day, you learn it in a day. This letter makes this sound. Every letter gets one sound. There's 2 that make 2. G either makes a G or a J sound, and C either makes a K or a Ch sound in Italian, and that's it. They're the only letters that make 2 sounds. Everything else makes 1, and it just follows the rules. Then English, it's like, okay, so this is the letter O, it makes all the sounds. This is letter A, it makes all the vowel sounds. This is letter E, it makes all the vowel sounds. This is letter I, it also makes all the vowel sounds. This is letter U, it makes all the vowel sounds. This is letter Y, sometimes it's a vowel, sometimes it's not. By the way, if you're wondering, does it make all the vowel sounds? Except for O, yeah. It's so dumb. Oh, English is dumb. Anyway, that's the end of my rant. And yet, beautiful. It's nice for poetry, because unlike other languages where, the endings of words always rhyme, and so rhyming is a real lazy thing, because just, you think of French. There's only 4 ending sounds, right? In English, your ending sounds are all over the place. So it's a great language for, rhyming and creativity. Bad language for making sense or being logical. And I cannot imagine having to learn it as an adult. Anyway, this is done, except it's not balanced. This says 1 aluminum, but over here we know we need 2 of them. So, this is a classic case where we're just going to say left side, right side, and I promise you right now that this one's going to be annoying. At least I found it annoying. Maybe you got it right away. But we have aluminum, we have oxygen. On the left, how many aluminums? Great. On the right, 2. On the left, how many oxygens? Yeah, there's 1 of them, but there's 2 in each one. So it's, damn it, then I did. 2 oxygens. And then over here, how many oxygens? 3. Okay, this is the annoying part because there's no nice way to turn a 2 into a 3 because you're not allowed to say, well, I guess if we multiplied this by 1.5, not allowed to do that until you are in grade 11 chemistry. But for now, you're not allowed to do that. So, we have to, this is like, in fractions, you have to find like the lowest common denominator. It's kind of like that. What's the lowest common denominator of 2 and 3? You can't get 3 to a 4. Not by multiplying. Not nicely. I mean, you can do it, but not nicely. Yeah, we got to multiply by something. So when in doubt, if you have an odd number, just double it. If you have an odd number, and I'm going to make a little note here. If you can't make an odd number work, just double it. By the way, when I say odd number, what are the odd numbers? What are the odd numbers? 1, 3, 5, 7, 9, 11, 13, blah, blah, blah. They're all the numbers that aren't divisible by 2. Yeah, because 2's come up so much, a lot of times, not every time, but a lot of times when you have an odd number, it's going to screw you up. So if you have an odd number screwing you up, just put a 2, but obviously, can I put the 2 here so it only affects the oxygen? Or is the only place I'm allowed to put numbers? In front. So I have to put the 2 here. What's that going to do to my oxygens? How many do I have now? 2 groups of 3 is 6. Good. But what else does it change? The aluminum. 2 groups of 2 is 4. Okay. And now we can work on the left side. How many aluminums do I have on the left side right now? 1. But now I need to get that to, so that's easy. What do I put in front? Yeah, just 4. Good. And that's going to change that to 4. Good. Now that works. And then what needs to go in front of my oxygens to make it equal 6? But 6 times 2 would be what? 12. So that doesn't work, but you're close. 3. Beautiful. Very good. So I think that's really tricky to balance. To me, that's a tricky one. You'll probably screw these ones up a bit when we're starting out, and it'll take you some time to get good at them. If you're perfect at them right off the hop, that's really good. That tells me that you've got really strong mental math skills. That's great. Oh, I would replace it with what now? 3 times 2 is? 3 times 2 is? Yeah, 6. Beautiful. Which means that it is balanced. Thank you. Sorry, I would have been annoyed if I'd forgotten to fill that in. So yeah, if this is coming to you really quickly, that's a good sign that like you've had good math teachers and you're a good natural math student and you've got like good mental math skills. It took me a while to learn this. I'm pretty good at it now because I've been doing it for, I don't want to say how long, probably 28 years. That's a long time. I was just realizing today that my car, I know the manufacturing date of my car because I had to look up the VIN number once. And my car just celebrated its 16th birthday. And I was mindful of the fact that my car is older than a lot of my students, and that made me sad.
Your car can legally drive.
My car can legally get a beginner's license now. My other car is self-driving, and it's only 2. So I figured that out. Meanwhile, my 16-year-old car cannot drive itself. If I just took my hand off the wheel, and the alignment on that thing is really shot. So if I took my hands off the wheel, it'd go like boom and like immediately plunge into other traffic. So we gotta keep our hands on the wheel. Alignment was good, and then Greg put her in a ditch, and now she's not quite as well aligned. But I don't want to dump money into it because it's 16 years old. I'm just gonna drive it till it like catches fire.
I'm sure the transportation kids would love.
Yeah, well, I'm excited actually. When she dies, I'm gonna donate to them because they've never had an electric car there, right? So that'd be cool for them to have a chance to, take a look at that.
Greg Keller, I wonder if we still have
Is anyone in transportation now? Is the half a PT Cruiser gone? They had my last car for a while. They stripped it right down and...
Walk in, you go to look there to the left for a while. There was just the front half of a PT Cruiser just hanging out there.
Like the red frame.
Yeah.
It's still there? There you go. There you go.
It's like the frame, the two front like seats, and the steering wheel.
When I bought a different car, I had this old piece of crap 1999 Grand Am, and it was like coming up on like 17 or 18 years old. And I was like, the day this thing dies, I'm going to buy my wife a new car. And one day in the parking lot here, it wouldn't start. So I had the shop guys come and they like towed it on over, dragged it. I don't know what they did. They got rid of it anyway. So it was over there. It was great. And then I was like, great, I'm buying a new car. And then the next day he came over. He was like, oh yeah, there's just corrosion on your battery terminals. We sanded that guy down, fired right up. I'm like, don't tell me that. I want a new car. So I got like 2 more years out of it. I was like, ah. Anyway, I hated that car. I hated that car so much. Nothing worked, but the engine wouldn't die. The windows wouldn't go down. The radio had been stolen. It was just a big blank spot in the middle. The radio had been stolen in like 2003, and nobody bothered to replace it. Like the heater, yeah. People used to steal car radios because it used to be, now nobody does this, but it used to be that the radios that came with cars sounded like absolute junk. So if you were remotely into music, you'd install your own. So you'd buy an aftermarket stereo, aftermarket speakers, take the dash off, you'd take the door panels off, you'd install your own stereo. And then, inevitably, in my case, twice, you'll be at a concert in Rochester, New York, and all of a sudden you'll come out of your concert and go to your car and be like, someone stole my radio. And like, just boom, now there's a big hole in your dash. So then they started making radios where the faceplate could come off with all the controls on it. And so you'd shove that in your pocket. So then nobody's going to steal a radio that you can't control, right? So for years, that was the whole thing. You'd buy these aftermarket stereos that had like this faceplate that popped. Ask any of your parents about like the era of like radios that like pop up. Yeah, because if you want a CD player in your car or something like that, like this is before streaming or whatever, obviously, like car stereos had cassette decks for the longest time. So if you want to be able to put a CD in, my first car, I ripped the center console out all the way down. I installed a CD case that went down the length of my car so I could keep like 60 CDs in my car. And that was like I was like, I got all the music I could ever want. It was a barbaric time. You guys have no idea. Yeah.
My dad had this car that he crashed into a ditch about like 12 times. And one time we went to his house after, like for the weekend that he had us. And then like we walked into his car and it wasn't his car. And we were like, oh, what happened to your other car? And he just casually told us that it like exploded in the driveway.
Have I ever told you my wedding story? Oh, so the day before I was getting married, this is 2005. So this would have been July 29th, 2005. I remember my anniversary. So July 29th, 2005, I was moving. I still lived with my parents out here on Ridge Road, but my wife and I, girlfriend at the time, I guess, were renting a place. So I was moving the last of my stuff. We'd been there for a few weeks, but I was going back to my parents' house to get like just everything, right? Like my CD collection, my guitars, a few of them that were left, my clothes, just stuff. My car was loaded high, and I was driving this piece of crap 1989 Mercury Topaz that I'd bought for $105 and like never put $1 of repair work into. And I'd gotten like 3.5 good years out of this thing, but it had really started to like, it was misbehaving. It used to burn oil like crazy. And I'd be like in the drive-thru at Tim Hortons and people would be like, your car is on fire. I'm like, no, it just does this. It's a thing. As like black smoke would like go up. So anyway, I got off the highway at Victoria Avenue for where my house was that I was renting. I get off at Victoria and I didn't have air conditioning. But so I was coming off the highway and so I was putting the windows down because I was like, well, now I'm off the highway. I can put the windows down. And all of a sudden, I don't know what happened. I put the windows down, and not out the windows, but out the vents. All of a sudden, just thick black smoke. Like, just act like I was choking on it. So I was like, oh, no. So I pull over on the overpass over the highway, and I get out, and I pop the hood, and it just goes whoosh to like 30 feet in the air, just at this tower of flames. And I'm like, oh, no. So like, what do I do? All my stuff is in this car. The wedding rings for the wedding, my tux, the rental, like the cheese and veggie platter for like the rehearsal that day, my guitars, CDs, everything is in this stupid vehicle that is now just 20 feet of flames. So I go to open the front door and I just can't. Like the windshield is melting onto the front. So I'm like, okay, everything in the front is done for. So I open the back seats and I'm pulling them out and the fire is starting to spread. So I got maybe 2/3 of the stuff out of the back before the fire was just too much. And all of a sudden I hear this guy honking behind me. And I'm like, yeah, I know it's on fire. What do you want me to do? But it turned out it was a couple who we knew from church. So they jumped out and they were helping me pull stuff out of the trunk and get into their truck. And this is like, nobody had a cell phone at this time, but they had a cell phone, this big, like, ridiculous old cell phone. Like, and so we phoned Britt, and she was sitting with my mother-in-law at the place we're renting. And I phoned her and she goes, oh my God, there's like a big fire on the highway. Like we can see it from the house here. And I'm like, that's me. I'm the big fire. It's all my stuff. Come get me. So she came and got me and the fire trucks came and they ran the like skeletal hulk of my car, got towed to like an auto center. The next day we went and got wedding photos all around like this, melted mess that used to be my Mercury Topaz, but all my clothes burned up. So I had no clothes, like half my CD collection. So like I have my like childhood CD collection from A to L, and then I think from like T to something, like T to Z, but there's a big gap in the middle where they all caught fire. I lost a guitar. Yeah, there's a bunch of stuff. But then imagine this. Imagine going to, and the worst thing, I worked at this restaurant. I'd been there for like 7 years at this point. And this is what back when I was making $6 an hour and like $1 a table getting tips. And my coworkers had raised $1,450 for me as like a wedding gift. And it was in my glove compartment. It caught fire. So now I had to phone insurance and be like, yeah, my $100 car burned. Also, I had $6,500 worth of stuff in it. And they're like, oh, did you? So they sent this like forensics team to like the wrecking place to like go and like, they had like tweezers and stuff. And they're poking through it to see if there was evidence of what I was saying. Anyway, I got my claim. So for a $100 car, I got like an $8,000 insurance claim. So that's a pretty good deal, really. Anyway, the moral of the story is, turns out there'd been a recall on the car, and there's a little solenoid along the master cylinder of the brake system, and that had a habit of sparking. And then if there's a leak in like the brake fluid, that had a habit of catching fire. And it turns out she caught fire. So moral of the story is, buy cheap cars and you don't care what happens to them. That thing didn't owe me anything. We had good years together. I broke down in 4 different provinces with that car. I had to get jump-started in Ontario, in Quebec, in Saskatchewan, right? Like, so, we had times. Anyway, now, the thing to know about chemistry is that if you can make a reaction happen, you can also unmake a reaction happen. Does that make sense? In this case, we put aluminum together with oxygen, and we use that to make aluminum oxide. If we wanted to, we could take that aluminum oxide, and we could break it apart. And if we took the aluminum oxide and broke it apart, what do you think we'd get? Aluminum and oxygen. Does that make sense? Yeah. So that's the next reaction we're going to learn about, but it's really just the exact same thing. Does that make sense? It's just the exact same thing, but it's backwards. It's just undoing what we just did. And we call these decomposition reactions. What does it mean for something to decompose? Yeah, break down. Perfect answer. That's right. So in this case, we have some compound, A question mark, B question mark, whatever it may be, and it's going to break down into its parts. And here it says, let's look at an example. Let's break down calcium nitride. So the problem with that is I need to know what calcium nitride is. Calcium nitride is a compound. We can tell that because it's got that "ide" ending, IDE. It's a compound that's made of calcium, and out of nitride means that it's calcium bonded to nitrogen. Very good. So when calcium comes together with nitrogen, how many electrons does calcium want to give away? We look at our periodic table, and we see it's over here, which means it has 2 electrons to give away. Very good. Man, you guys are picking this up quick. Who taught you last year? Oh. Well, someone in Toronto and your dad, and who'd the rest of you have? Trush? Well, someone in Toronto, your dad, and Trush, they get flowers from me. They're doing great. So 1 calcium could give away 2 electrons. See, when the ones I've taught in grade 9 come to me, it's like I once taught a grade 9 class and I had like half of them again in grade 10, and like the half who I taught were all like, yeah, like we didn't learn this last year. We didn't learn anything. I'm like, damn, that was me. Really hurt my feelings. Anyway, that's the end of my story. 1 calcium would lose 2 electrons. 2 of them could lose 4. 3 of them could lose 6. And you could keep going. What about nitrogen? Each nitrogen needs to gain how many electrons to get a full shell? Very good. And this is that annoying 2-3 mix again, right? We hate that annoying 2-3 mix. So 1 nitrogen would lose 3 electrons. 2 of them would lose 6. 3 of them would lose 9. We could keep going. And obviously, where's the nice meeting place?
3 and 2.
Very good. Yep, exactly right. 3 calciums, Ca3, will give away 6 electrons, and N2, 2 nitrogens, will be able to accept those. Now, the nice thing is, the products are super easy to figure out. What are the 2 products going to be? Well, one of them is going to be calcium, and the other one's going to be nitrogen, and they're just going to be on their own. In a decomposition reaction, the things end up on their own. So calcium's going to end up on its own, and nitrogen is also going to end up on its own, though we need to remember something about nitrogen when it's on its own. Remember that hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine are all what we call the word Hofbrinkel, and they're the diatomic elements, which means we always find them when they're on their own, not when they're in a compound, with that little 2 on them, which means that, is calcium one of these? No. Oh, God. Darn it. Yeah, calcium's fine, but nitrogen has to be written as N2. Now, this one isn't as bad to balance because of where the 2 is and where the 3 is. This one's pretty nice. Take a minute and balance it. My grade 11's last period broke 2 pieces of glassware in one lab. I was apoplectic. So annoyed. It was clumsy. One was just a test tube, which is fine, and then one was a graduated cylinder. That's like $27 that I'm not made of $27 right now. You know, when I was in high school, our science department either made you pay for everything you broke, or you had to buy insurance for $5 a semester that covered you for accidental breakage. And even then, if you broke anything, you had to spend that lunch on glass cleaning duty. They didn't have a dishwasher.
I'm pretty sure the grade 12 class last year chipped a test tube, but I don't think we straight up.
And like the truth is, test tubes are cheap. Like test tubes are actually supposed to be disposable, like kind of one-use sort of things. Like that's fine. They're cheap. I can buy a 64 pack of test tubes for $40, like whatever. Good ones are $100. Yeah. Yes, you may. Right? This is what I'm saying. I was very annoyed. Very annoyed. I had stern words. I said, you know how many things my grade 9s have broken so far this year? None. You know how many things my grade 10s have broken so far this year? None. And here we are, my seniors, supposed to be the senior science students. We're breaking stuff at this rate? What the hell is wrong with you people? That's what I said. Never mind. So it doesn't matter. It doesn't matter because we're a team. We succeed together. We fail together. Every bit as much my failure as theirs, but especially theirs. It's not about individuals. It's about collective effort. All right, team, let's take a look. On the left side of this thing, how many calciums? Yeah. Sorry? What do you mean? Why isn't it Ca2N3? Is that what you're asking? Can you show me? Can I take a look?
One side is 2, right side is 1.
Can I take a look? Yep, exactly right. So here, the reason is because here we're breaking something apart. So that's exactly the right question. It's a good question. So the answer is when we put them together, we call that a synthesis reaction. And when we break something up, we call it a decomposition reaction. And they're both possible. They both happen. They're not just both possible, they both are real. They both happen all the time. So, calcium nitride, how many calciums do we have on the left?
2.
Nope, careful.
Sorry, 1.
Nope.
3.
3, good.
Oh, yeah.
That's okay, don't be sorry. How many do we have on the right?
1.
Excellent. Stop that. How many nitrogens over here?
2.
Very good. And how many nitrogens over here?
1.
Only one N2, but each N2 has how many nitrogens?
2.
Very good. Oh, it disappeared. I know, it's annoying. It's trying to be helpful, but it doesn't know that I'm the type of person who likes to go like this. Does he? Well, I'm glad to have company. So this one's actually not bad to balance at all. What's the only thing we have to fix? The calcium. And the problem is on this side, and how many do we need? 3. And this is a nice case because it's not one of these things where fixing it made a new problem. We fixed it, and everything else is just chill. So that is now balanced. Calcium nitride will break down into 3 calciums and into 1 nitrogen gas. Does that make sense? By the way, if we were to do this as a synthesis reaction, it would be the exact same, but just like Flourish said, if it was a synthesis reaction, the only difference is these would be the reactants, and that would be the product. Okay. Does that make sense? All right. So now, the last one we want to look at is the decomposition of aluminum oxide. And the clever amongst you might note that we've already seen something very similar, but I want you to try this one on your own. Toby's here to help. I will be here to help in a moment. I do have to go ask Miss N something, but I want a balanced chemical equation for the breaking apart of aluminum oxide. Give it a shot. Get to it. Get on it. You got this. Aluminum oxide. And again, if you want to know the formula for aluminum oxide and you want to save yourself some time, we did that on the previous page. Yeah, so we're going to go, and here's the nice thing, is if we write it in words, aluminum oxide, which we'll need to figure out the formula of, when it breaks down, what's it going to form? We already know this. Aluminum and oxygen. So, you already know that. And do we know the formula for aluminum? Al. And do we know the formula for oxygen? O2. So the only formula you need to figure out is that one. And then you'll need to balance it. Figure out that formula, balance it, you're good to go. I'll be back in 2. Toby's here. So, like we said, you probably, from the previous page, we don't need to work aluminum out again because we already worked it out. And the formula of aluminum oxide is what? Al2O3, because aluminum can only gives away 3 electrons at a time. Oxygen can only take 2 of them. So 2 aluminums can give away 6 electrons. It takes 3 oxygens to receive those. So we get Al2O3. And then we're right back to that miserable balancing. Again, this is the annoying one. On the left side, how many aluminums do we have? We got 2. On the right, of course, we only have 1. We could fix that now, but I'm going to hold off because oxygen, how many on the left? Yep. And on the right? Yep, beautiful. Okay, so now we said that if you've got that stupid odd number that's not going to work nicely, what can you do with it?
Multiply it.
Yep, multiply it. And when in doubt, what's a good thing to do with it? Double it. What's doubling mean? Multiply it by 2. 9 times out of 10, that'll get you there. Other times it'll be uglier. So that means I'm going to just put a 2 in front of here. What does that change? It changes the aluminum from 2 to 2 times 2 is 4. And it changes the oxygen from 3 to, very good. Now, I need to fix the right side because I need how many aluminums now? Yep, but I only have 1, so that's easy. What number goes in front of here?
4.
Yep, but this one's a little trickier. I got to remember we're doubling whatever we put in front. I need to get oxygen to 6. What do I have to put in front of here to make 2 turn into 6? Very good. Yep, exactly right. And now they are balanced. That looks terrible. Let me try that again. That still looks terrible. I think my cursive is getting worse, and it was never that great to begin with. I'm sure I've asked this. How many of you know cursive? How many of you would say you're pretty good at it? My mother has like the world's most beautiful cursive. She was a school teacher, and she's got that teacher cursive writing. You know, the one where it's just like, it just looks absolutely perfect. Her printing is perfect too. I should get her to like just come into my class and just be my writer. All right. I want you to try and do this one for homework. But then the other thing I want you to know is that this note tells you how to answer that question 3 on your lab report. Remember that lab where we said the one question was write a balanced chemical equation for what happened when we burned the magnesium? Now you should be able to do that. Magnesium should react with oxygen. Of course, what do we have to write oxygen as? O2. You should be able to figure out the product, which will be called what? Magnesium. Very good. You should be able to figure that product out and balance it. All right? So that lab report's going to be due tomorrow. If you need help with that, of course, you can come to me at lunch. You can come to me after school. You come to me in the afternoon if you can get out of your class for a minute. You can also message me on Teams. I've only had one person in this class do that so far. Why did I say that way? So far, I've only had one person in this class. It sounded vaguely Slavic. I can't do a Slavic accent, I don't think. Should I try? Maybe it's insulting. You'll do homework and send me question if you don't know how to do. That's not very good. Can anyone here do a Russian accent? Anyone? Anyone got like a Russian uncle? Go for it. Okay, give it to me. Go. That was pretty good. That was better than mine. I like it. Heimple, I feel like you got one hanging out in there.
No, I don't.
Do you not?
Surprisingly not,
No? When I was editing last year's play...
Stop. No, I know I do like random, I know there's random bits where...
No, not when you were on the stage. It was when you guys were backstage. Of course, the mics were muted, but they're still recording. So yes, so I was hearing all this like voice work from the back that I'd have to go find and mute out. And I mean also like conversations where I'm like, I don't know that I want to be hearing this right now. But the voice work, I was like, oh, that's right, it was a Scottish accent. Go for it. Give it to me. Oh, come on. All right. Yes. I like V for Vendetta. Do you guys do Watchmen as well? I was like when they do Watchmen, because you know Watchmen's dedicated to Joe Orlando. Beautiful. Yep, exactly right. Well, is that making sense for you? You feeling pretty good about that? You're doing well. All right, guys, when's your lab report due? I mean, it's not a report, it's a worksheet. But when's your lab worksheet due? Tomorrow. Make sure you have it for me, all right?
Are you gonna check it in the morning?
I'm going to collect it. I'm going to grade it. Yeah, I'm going to collect it and grade it. So make sure it's done. And then we're going to do another lab tomorrow, so be excited.